Um, yeah, just three talks today. So I guess it's 1 o'clock, so we'll get started.
Sure.
This is
Uh,
the third of four rounds of MGIS Capstone presentations. Each talk will be 15 minutes. So if you could keep your talk to like 12 or 13 to leave some room for questions, that would be great. Um, so Drew, you are up first. So if you are you able to share your screen?
yeah, I'm gonna try and share my screen and pull up the. Can y'all see my screen?
10. Yep.
Okay.
There you go. All right.
Hello, everyone. I'm Andrew Toller,
Oh,
and my
I have the recording on here. Okay. Sorry about that.
All good. Looks good. Take it away.
All right. Hey guys, I'm Drew Tolley, presenting my capstone project today. My topic was using GIS to identify areas for long-term return on investment from rental income in Fort Walton Beach and Destin, Florida. The agenda and topics I plan to cover today are the project goals and objectives, the discussion of previous research, proposed data and methodology, some conclusions and results, and then time for questions at the end. So my goals of the project were to identify regions of the study area that were ideal for rental investment. So I picked a few different areas, which we'll talk about in a second, and then utilize Esri's business analytics online data through the Mosaic Prism segments and Zillow, in addition to the American Community Survey data as well, to inform decision-making on finding the ideal areas for investment. So previous research centered primarily on kind of bigger scope. So real estate return investment risk. There was a study conducted by Benjamin, Sermons, and Zeitz that found highlights of the real estate provides stable long-term income potential, requiring careful location analysis. There is additional research on housing market predictions, which focused on GIS predictive, is auto cycling, and valuation modeling with different indicators for long-term income, capitalization rates, and then how government policies and market dynamics affect real estate, specifically zoning laws, tax incentives, that sort of thing. So my proposed data and the data that I ended up using and what I did. So demographic data suitability analysis from Esri BAO, Prism My Segments, the American Community Survey, the Tapestry segmentation, and then how I went about actually conducting the research. I used Esri BAO and then ArcGIS Pro, conducting suitability analysis through affordability and renter suitability, which we'll talk about in a second. So these are my study areas: Fort Walton Beach, Shalimar, Niceville, Valparaiso, Blue Water Bay, and Destin, all kind of in the Emerald Coast area of Florida. And this is actually where I'm currently living, and that's why I decided to do this study, because I'm also interested in getting into maybe property management of some form. So to kick it off, my research, and this kind of column-based graphic, I really liked how this developed and how I was able to get this to look. The columns from left to right: Destin, Blue Water Bay, Niceville, Valparaiso, Shalimar, and Fort Walton Beach, all the study areas. And then drawing data from the American Community Survey, I was able to get this to pull into each category. So household income, per capita income, home valuation, educational attainment, and then down on the bottom in the key facts area that I broke out there for the individual number, the population, number of homes, and median age. So across the board, you can see a wide range of net worth, home valuation, household income. Blue Water Bay being the wealthiest area among the study group, and then Valparaiso being moderate income, Shalimar little less, and then Fort Walton Beach even more so. So from about 66,000 up to 114,000, and then that median net worth value basically from about 145 all the way to nearly 600,000, with educational attainment rates widely varying by neighborhood, and from 50+% to about 30% with bachelor's or higher. And then the median age was fairly stable across all of them, being between about 38 and 45. So middle-aged demographic, median age-wise. I did the same, so following the same columns with Destin on the left, Fort Walton Beach on the right. This is what I was able to find with the average rental rate, and then mortgages, census-based household size, and then rates of home ownership. So the average rental rate does not include utilities or taxes or anything like that. Is just the straight rental rate. Same thing with the mortgage in the second row there, with variation, and this is data from 2023. So before the kind of uptick in mortgage rates is where this data is coming from. The household size, this was kind of surprising to me. I expected most homes to be occupied by about 4 people. Kind of the standard American household is what I assumed. That is not the case. The majority of household sizes were 2-person occupants. And then the household ownership rates surprised me, with Fort Walton Beach actually being fairly split evenly in terms of ownership and rental. And then Blue Water Bay had a very high percentage of home ownership. So the dynamic between Blue Water Bay and Fort Walton Beach was kind of surprising to me. Just driving through these areas personally, I assumed a more closely even split amongst all groups. So the results. I did the affordability analysis heat map from ArcGIS Pro. I basically migrated the data from BAO into ArcGIS Pro and conducted the analysis that way. The suitability final score, 0 being better. The higher the score, the less suitable, if you will, the area, basically comparing the acquisition price of a home to the availability of renters and other associated kind of costs, if you will, with the cost of the acquisition to the rental rate for the area. So in this case, Valparaiso scored the best. That's kind of that light beige, color. Next to Niceville, followed by Shalimar. Fort Walton Beach and Niceville scored approximately the same. Blue Water Bay and then Destin were not suitable based off this analysis. And then the second piece here, the renter suitability. So the vacancy rates of rental homes compared to the availability of the properties themselves. So where are the renters deciding to live, basically, is what this is showing. So in this case, Shalimar scored the best, again following the same metric. The lower the score, the better the outcome. with Fort Walton Beach and Blue Water Bay bringing up the rear in terms of optimization of renter availability and suitability. So conclusions. The prime areas for investment based off this, Valparaiso, Shalimar, Fort Walton Beach. This was really surprising to me. I'm going to go back a slide for a second. I expected Destin to be kind of that prime area for rentals, just based off the assumption that that's where everyone likes to go on vacation. But my research scope was long-term rentals, not short-term rentals. And it turns out, which after I thought about it for a minute, that it would make sense that Destin was actually a better market for short-term rental, like Airbnb or hotels, rather than a true rental home, which back in the demographic data from the American Community Survey, most folks living outside of the Destin area were professionals in some capacity, either owning their own business or employed at one of the military bases in the area or in the local economy. So the folks that were living there were full-time residents effectively. And that's what a longer-term rental effectively is, and that's where it fits in the market. And that was a big learning point for me personally, because I was going in with assumptions that the research ended up not supporting. So this was actually eye-opening to me personally in that regard. The other piece is the home values in Destin tended to be higher, which drove that reduction in suitability. So the cost of acquisition of a property in Destin compared to, for example, Valparaiso, there's a $300,000 difference between the two locations. And that's what drove that lower suitability. Additionally, the availability of long-term renters in Destin the market just was not there for it. So that was interesting. Between Valparaiso and Shalimar, that would require a little more research because they're very similar in terms of the market and total acquisition cost. I marked Valparaiso as number one, just purely based off the acquisition cost of the average property to support two people. So effectively a three-person or a three-room home or smaller. Additionally, the proximity of major sources of long-term employment. It's demographically suitable for local incomes. And then proximity to entertainment, being access to those bridges, and then the coastal environment as well, with the beaches. So that concludes my presentation. I guess if anyone has any questions or discussion.
Thanks, Drew. That was well done. There are a couple questions in the chat. If you're okay, could you just read those aloud, just so they're for people who can't see them? Just read those aloud.
Yeah, sure.
Do you see them okay?
Yes. Okay. I guess I can. Do you want me to stop the share? Or I can just,
either way is
I can
fine.
just do it this way.
Yeah, but if you could just read. Yeah.
Great job, Drew. Quick question on suitability analysis. How was that performed in ARC Pro? How did you select the inputs, income, home ownership, determine what equaled prime rental market? Did you have to do a lot of data cleaning to get it to run? So this question comes from Teresa Olson. The way that I did a combination of analysis from BAO so within BAO was it tied the community survey data in there. So I did not directly change the data itself. I used the outputs from BAO, loaded it into ArcGIS Pro, did the suitability analysis off of the income from the survey, and then the home ownership values that I put in that pie chart. I used those in conjunction to kind of get that output, and then determining what the prime rental market was. I was going in with kind of an assumption that the prime rental market was an area where the acquisition of a property was low with a high probability of filling it. So vacancy rates were a big thing. And then the price of the acquisition was a big part of that. So Valparaiso, for example, had low vacancy with low price of acquisition. So that's basically how I came up with the determination that Valparaiso being the prime suitability, if you will, for that. So I hope that answers your question there. Feel free to drop another question if you have another one there. And then Dan Snyder, thanks for presentation today. Did you find the Zillow home value matched the Esri BAO rates? So there was a data section in there, the ZHIV, which was a Zillow home index, and it was pretty similar if you use the same categorization from 2023, which was where the data was coming from. And it was relatively similar. There was approximately $280,000 to $320,000 for the size home, the 3-bedroom or smaller category that I was looking at there. So in terms of the accuracy or relative value matching, I would say the answer to that question would be yes. And then Juan, is this project only for your own research, or do you plan to share it with other people? There is an element of, I wanted to do this because this is something that I would like to do. I'm currently in the military, so I'm looking at maybe post-military stuff. Being out here in the Emerald Coast, I was just looking around and like what would be an alternate career path, and that's kind of what drove the topic of this research. And to share it with other folks, I certainly would. If other folks, this is a very focused project, but if you will, the methods that I did it can be applied anywhere. So the results of my project are very local, but the methods could be applied in other parts of the country. Like if you're in Denver or in College Station, or another area, maybe even up around Penn State. So I hope that answers that question. From Juan.
Thanks, Drew. If you don't mind, just throw your email in the chat in case anybody has any follow-up questions. Sure. Yeah, thank you for that. So if you could stop sharing your screen, and then Matthew, see if you can share your screen.
Yeah, I'll go ahead. All right, can you guys see that?
Yep, looks great, and I can hear you, so perfect. Take it away.
All right, so this is the presentation of my capstone project, the spatial analysis of unhoused populations and aid services in the San Francisco Bay Area. Just a little about me. I am currently not working in GIS, but I'm hoping to change that. I am working as a part-time librarian, and I interact frequently with the unhoused, which served as the inspiration for this project. So a quick overview. The main goal of my project is to better understand the distribution of unhoused people and the services they use. That goal can be broken down into 3 main objectives. First, understanding the distribution of unhoused people and aid services. Second, determining how accessible those services actually are. And third, determining if there are any relationships between unhoused people, aid services, and then other factors, say unemployment rate or average rent. So why does this matter? At the moment, there are over 300,000 people in the US experiencing homelessness, and there are almost 30,000 alone in the Bay Area. So I figured this would be an important topic to focus on. Just a quick rundown of the study area. You can see on the right side, I have a map just kind of listing the different counties I studied, as well as the unhoused population within each. On the top right, we have Contra Costa County. Below that is Alameda. Below that is Santa Clara. And to the northwest, we have San Mateo. And above that is San Francisco. There are other places that are considered Bay Area, like Marin County and Napa, directly above my study area, but it's much more rural up there, so I figured it wouldn't be super useful compared to the more urban South Bay. So previous research on the topic has focused primarily on the role of GIS, the benefits that services provide unhoused people, as well as the benefits of being near the services that people use. So GIS itself has been shown to be very useful in providing insights into the spatial implications of homelessness, as well as planning where new service locations can be. Homeless services themselves provide people with opportunities and assistance they might not get otherwise, which is very important for helping people get back on their feet. And lastly, the proximity of services. Being near a service will increase the use of that service as well as the efficacy of the service being provided. One study even found that homeless students performed better when they were living at a shelter closer to their school compared to kids who were further away. So a quick overview of my data. It consists of some boundaries, population data, demographics, service locations, and transit data. On the right side, I have a clip from one of the pit reports I used to get my homeless count data. As you can see, they include a lot more than just the population data. They have a lot of demographic data that might be useful for a different kind of analysis on homelessness. So going into my boundaries, I have my county boundaries, my supervisor districts within each county, and then the cities. The county and city data both came from CAL FIRE, and then the county supervisor districts I got from the county specific GIS portals. So the counties I included mainly because funding for homeless services is dished out at the county level, whereas the pit reports counted the unhoused counts within each city. So I decided to use the counties and cities. And then the supervisor districts I included because it's just another way to further refine my data. And for San Francisco specifically, I wanted to use the supervisor districts rather than just the entire city itself, since the city of San Francisco is quite large and that would kind of mess with the data from the other cities. So the population and demographics data, I got my population counts from these pit reports. The Department of Housing and Urban Development requires counties complete these reports every other year. Essentially what happens is the county will choose one day of the year and will send out a bunch of volunteers. These volunteers will do a count of all the homeless people in the city they're assigned, as well as some other general questionnaire stuff. The demographic data, mainly the average contract rent and the unemployment rate, I got that from the census and the American Community Survey. So the next piece of data are the service and transit locations. My service locations were provided by a 211 Bay Area. This is a local nonprofit that aims at assisting people who are homeless or near homelessness with just partnering them with different aid services that might be useful. The list is very extensive, but not exhaustive. So I had to use Google Maps to fill in any places that weren't on their website. And to do that, I just geocoded all the addresses and got some coordinates for each address and just created a point data set from that. For my transit data, both sets came from Caltrans. I have a list of transit stops. This is point data of all the transit stops in the Bay Area. And I also got street centerline data. So just an overview of my methodology, I focused on the spatial autocorrelation of my data, mainly the dispersion of my dependent variables. I did a network analysis. This is just to determine the accessibility. And then the statistical analysis was to understand the correlation. So for the spatial autocorrelation, I mainly will be using GeoDaw to generate my results. The network analysis was done all in ArcGIS, and then the statistical analysis was all done in R. So to briefly discuss spatial autocorrelation, I will use Morin's one statistic to measure the similarity of values at different locations. This value can be positive or negative, ranging from -1 all the way to 1. 1 represents strongly clustered data, while -1 represents strongly dispersed, and a value of 0 would represent random dispersion. And to visualize that, I will use a LISA map, or a local indicators of spatial association. This is just a cluster map that visualizes which parts of the study area contribute the most to that statistic. Next is the network analysis. This is going to be broken up into two parts. First, a closest facility analysis, and then a service area analysis. So the closest facility analysis will just take, you have two sets of point data, facilities and incidents, and this will calculate the fastest route from a facility to incident. And so I'll use this to figure out the average time it takes to walk from an aid service to the nearest transit stop. To calculate my travel time, I'm using a pace of 210 feet per minute. That is just the average walking pace of an adult in the United States. The service area analysis essentially creates a time-based buffer around a point. And on the left, I have an example of what an output for that would look like. So all the blue areas represent the that service area. And so on the left, I used a service area of about 30 minutes. So that means if you're anywhere within that service area, it will take no more than 30 minutes to get to the service location. Lastly is my statistical analysis. This is just to study the correlation. My explanatory variables will differ based on my dependent variable. So when I'm looking at the unhoused population, I will be mainly looking at the average rent, the unemployment rate, as well as the aid service count in each city. And then for the aid services, I will be mainly looking at the unhoused populations within each county, as well as the county level funding. For my regression, I was planning on using a Poisson regression, just since I'm using count data, and I know it has specific requirements. So if my data is over dispersed, I will move over to a quasi-Poisson or a negative binomial regression. So looking over the results of my spatial autocorrelation, overall, I found that there was a weak dispersion and clustering among the whole study area, and that was really just dependent on my input data. So looking at the unhoused individuals, when I looked at the entire bay, I found a statistic of 0.561, which I would say represents a moderately clustered data set. Not as strong as I was hoping to see, but still shows some clustering. But then when I looked at the individual counties, I was given a much different picture where there was pretty much no autocorrelation in each area. San Francisco had the highest statistic with 0.205, but even that is still not a very strong relationship. And for the aid services, the entire bay, I got a value of 0.151. That is very low. I would say essentially just randomly dispersed at this point, with the most significant value being 0.257 for Alameda County. Next is the results from my network analysis. So for the closest facility analysis, I found an average travel time of 13.5 minutes. As you can see, the standard deviation is almost a little over 2 times the mean. So my data is pretty skewed, meaning the median might be a better representation of the actual travel time. But even then, 13.5 minutes is a relatively short distance to travel between a service location and a transit stop. For the service area analysis, I found that there are about 86 transit stops within a 30-minute walking distance of a service location. And then I also found that there are on average 2 other aid services within that 30-minute service area. So overall, I'd say this means that the services are relatively accessible, as you're always kind of near means of transportation to travel between the services, or you're within a reasonable walking distance. So first, I want to look at the statistical analysis results for my county level data, which is the aid service locations. So for this, I first had to test to make sure my data actually fit the Poisson distribution. And the Poisson distribution basically assumes that the mean and variance are equal, which means that they have a dispersion parameter of 1. I calculated an R that my dispersion parameter for the aid location data was 1.4836, obviously bigger than 1. So I also then ran the quasi-Poisson dispersion parameter, and I found that to be 1.457. So my data was still even more dispersed than that, meaning I switched over to the non-binomial regression. As you can see on the right, I have my results. I found there was no significant relationships between the number of aid locations and the number of unhoused people, and the level of funding. At the city level, I did the same thing. I tested my data, this time the unhoused count data. I found that it did qualify for the quasi-Poisson, but I opted to do the quasi-Poisson and then the negative binomial regression as well, just to have both. I found that aid services were considered to be significant in both tests. I opted to display the results from the negative binomial regression just because it does create a generally larger coefficient values, which means there's less likely of a chance for me to falsely identify significance. And so with the significance I did calculate, I saw that there's a coefficient value of the 3.5 e to the minus 0.1. I exponentiated that to get the percent change it would add to the unhoused count. And I found on average a 1 unit increase in the number of aid services will increase the unhoused population by around 41.2%. So in conclusion, I found that the distribution of unhoused populations and aid services is they're not very autocorrelated. The unhoused populations lean towards being weakly clustered, while the aid services appear to be pretty much randomly dispersed. I did find that the aid services are relatively accessible via public transit just because it does take less than 15 minutes to walk from a transit stop to an aid service, and you're always near other transit stops and aid services as well. And then I did find the number of aid services did have a significant effect on the level of unhoused populations in each part of my study area. Future research on the topic could focus on a more fine-scaled population data collection, just because the most fine I could get would be at the sea level. They didn't go any lower than that. There's not any census data on unhoused people, unfortunately. And then the study area size, I think, played a big role in my results. I think for looking at, say, the county level funding and number of aid services, a study focusing on maybe the entire state would provide better results just because you'll have more data to work with. And that's it. I have my references, and then any questions you guys got?
Thank you. That was a great talk. Appreciate it. I have one question if other people are coming up with something. So did you just a clarification, did you say that you found that if there was an increase in aid services relates to an increase in the unhoused population? Did I get that right?
No, it was the other way around. The increase in the aid services will increase the unhoused population.
Will increase.
Yes, yeah.
Okay, yeah, that's what I thought you said. I'm just trying to think through that because that seems almost counterintuitive. You would think that if there's more services, it would help people.
Well, I think it's because the aid services, people will use those, and so I think homeless people tend to congregate around areas where those aid services are, is because they use them regularly, and so I think that's why we see the increased count of unhoused people near the aid service locations. Because yeah,
Gotcha.
they do help you eventually improve your condition and get out of homelessness, but in the meantime, you're mainly going to be kind of near those services while you use them.
Interesting. Gotcha. Hey, it looks like there's one question from Fritz in the chat. Could you just read that out loud and
yeah, so very nice presentation. More of a comment here. Given your non-significance findings, I would consider increasing your sample size. Some of your study areas have too few enumeration units for the regressions to statistically work. Yeah, I definitely agree. That's what I found with especially at the county level. I just did not have enough data to really get any meaningful, to find any meaningful relationships. So I definitely agree that increasing my sample size or just the study area would definitely improve my results.
All right. Well, if you don't mind, put your email in the chat in case anybody wants to reach out to follow up. And yeah, you can stop sharing and let's move on to the last talk of the day. Juan, are you able to share your screen?
Yep, one moment, please.
Sure. There we go. Looks like it's getting there. There we go. I see it. You may take it away when you're ready.
All right. Hello, everyone. My name is Juan Morteo. The title of my capstone is Revolutionizing Web Applications Through Data Stewardship, and it focuses on modernizing outdated GIS workflows in my current place of work. In this capstone, I'm going to be going over the background, why I'm doing it, some of the goals and objectives, previous research documented in a literature review, the proposed method and data use, the results of my capstone project, and some of the key takeaways. Part of my job is to maintain the Air Force GeoBase program and each installation must provide geospatial support and services across different mission areas. One of the common issues I've seen across the enterprise GIS is the inability to maintain an accurate real property inventory and also maintain the right information on space planning data layers. Traditional methods, as the ones you see on your screen, typically involve printing out a copy, going out in the field, writing some notes, bringing it back, uploading the information into the system of record. Other methods involve using more sophisticated softwares and embed the updates into static CAD file formats. There's nothing wrong with doing that. It's just sometimes it duplicates the work efforts, and sometimes the information doesn't make it into the right system of record. Just a little bit of a history here. The Air Force has been trying to implement enterprise GIS solutions since 2012. It worked at that time, but it required a lot of IT maintenance, server maintenance, and a lot of the GIOs at the time didn't have the certifications, and it created a lot more problems than benefits. Just moving forward to 2022, the Air Force have decided and have been invested in upgrading to a more robust cloud solution using Kubernetes and using the ArcGIS Enterprise solution. With this new shift, hopefully we hope to increase and address some of the issues that we've been finding over the years, such as inaccurate data from digitizing old maps, inconsistent topology from unsupervised editing, incomplete data from not having a good data stewardship program, and then the collaboration between departments is practically non-existent at the moment. Addressing all of these issues brings the Air Force GeoBase program closer to the speed and flexibility and efficiency found in the private sector. So introducing this cloud technology, it will bring the Air Force program forward towards fulfilling the GeoBase or the Air Force strategic vision. Some of the goals and objectives for this for my capstone project is to revamp the current data stewardship program, leverage the cloud technology to improve all of outdated GIS workflows, integrate other system of records such as the real property system of record and the geospatial side of the house, promote greater collaboration between the departments, and finally use the services provided through the enterprise by deploying web GIS solutions. So soon after the implementation of this proof of concept, the cloud-based deployment will allow data owners have greater control over their data, and GIS projects will now be planned based on the organizational needs and improve those workflows. As a key objective of this capstone project is to document every single step that I took to implement this solution or this proof of concept, and what information is required based on the lessons learned. I conducted a literature review to possibly understand prior work, and some of my core research included the role of the cloud computer interoperability challenges, increasing their reliance on mobile GIS versus on-premises solutions. And across all of the multiple journals that I came across in case studies, one of the recurrent issues was the poor data management and the limited collaboration between stakeholders. A lot of the, excuse me, a lot of the solutions implemented were in the forms of maps or maybe the result of a study, but never gave that chance for the stakeholders to continue to manipulate the data and continue to improve the data. It was more of a static snapshot in time rather than a continuous improvement and continuous development of a solution. As a GIS manager, my responsibilities is just to find those gaps and propose those GIS solutions to improve the data quality and the effectiveness of those solutions. Oops. The proposed solution for this capstone, it involves a web GIS application, and it's going to include capabilities for viewing, editing, calculating metrics, and collecting new data. I am a member of a larger enterprise architecture, so I am limited on the support and the funding that I have. So proposing this solution, I got to make sure that it is user friendly. The cost, it's minimal to the organization. It will include those multi-user collaboration capabilities, and it's going to stay here for not just a short period of time. We want to increase the capability of the system. The data sources that I'm using, there are proprietary data. We're using the space utilization data layers to include GIS and CAD features representing the interior layout of a facility. We're also including those CAD format facility layouts that are going to be all merged into one system of record, which is going to be our GIS for enterprise. And then we're also going to be including those paper copies, Excel documents, all of those reports that were provided during the facility allocation surveys and those facility walkthroughs. Once that information gets processed into the system of record using ArcGIS Pro as the software, it will feed directly into a web application. The proposed idea is for the user to access the enterprise and directly interact with the data on the things that they need to do. So after all of this time, I used and processed the data in ArcGIS Pro, and I came up with the proof of concept, which is a web experience application hosted in ArcGIS portal. The proposed platform includes a welcome page, which is going to serve as the user initial point of entry. You're going to have navigational buttons that's going to direct you to all of the different functionalities of the applications. It would also include a dashboard page. This is the dynamic interactive workspace focused on the facility space management. It has an interactive map and legend. It shows the facility layouts using the space utilization data layers. And it also provides information from the real property data source. It includes interactive widgets, so you can query layers from different floors available in each facility and all of the available space use types. Another functionality is the ability to click on individual spaces and edit the data directly into the system of record. One of the cool functionalities of this page is that any of the updates that occurred in here, it is saved into a version environment, so stakeholders do not have to worry about if they made a mistake or if they didn't make a mistake. All of this workflow directly, it's part of the quality checks that is managed by the geospatial office. So how does the application work? The user normally will log in and they will search for a building. Excuse me. Once they search for the building, they'll be able to further filter the data by selecting the available floors. As soon as a floor is selected, all of the widgets are interactive. You should be able to see the information from the real property, the source, the real property system of record, and then compare it against the space allocated within that facility. All of that information, it used to be just hosted and housed in a geodatabase, and it was never updated for over the years. With this new system now, I have the ability to provide this information, collaborate with the space planner, and they can start editing the information directly into the system, then go through the quality assurance and quality check process with the geospatial office. The dashboard page will also, another highly requested feature was the ability to compare or to view the metrics based on the space use type and the category code per each space. So on the bottom, you can see I included some charts to provide that functionality and that information to the space planners so they can include in their reports. The smart editing page focuses on one thing, which is allowing the data owners update the data directly. Again, they can search for facility numbers, and then, or they can select the data directly, click on it, and start editing the information using the smart editing widgets. Another option, and this is going to bring both of the collaboration between the GIS department and the space planning department. Anytime something happens, anything new happens, those updates will automatically be displayed in this smart editing page. There will be a list on the left side, and it would include what's needed or what information is missing. And again, just to mention it again, editors don't have to worry about editing the wrong data source. Everything will be into a control version environment. So later on, a GIS manager or a GIS power user can do the quality assurance checks that is required. So what are some of the big takeaways from this project? One of them, I was able to provide a GIS solution that is currently in beta testing at the moment. I hope to find some of the gaps in this statistical analysis and potential future upgrades to the application. This WebGIS platform has demonstrated a sustainable, scalable, and a secure way for accessing GIS data. And also, it involves the geospatial, the Air Force GeoBase program that has been struggling over the years to maintain a standardized model across the enterprise. Hopefully in the future, I would like to include additional functionalities that it will integrate Python script with web tools. A lot of the bulk editing will be done on the web rather than by GIS technicians. I will include additional dashboards. The space planner has already been making comments on some of the future uses that he may want to include additional data sources, additional tables that could potentially be part of this bigger solution. And also the ultimate goal is to be able to provide this information on the field, do offline editing, and really take advantage of all of the tools available through an enterprise solution. And that's pretty much it. And here are my references. And if you guys have any questions, please feel free to put them in the chat.
Thanks, Juan. That was great. It looks like there are already a couple questions in the chat. I'm not sure. Are you able to see the chat? You might need to stop sharing your screen to see the chat window.
Okay.
Yeah, and if you could read them aloud and then answer them, that'd be great.
So I believe one's from Drew.
Yep.
Is this application available at all installations? Can this be available at the squadron level? And we have a couple of geo inners attached. So each installation, I guess this is more of the military talk. I believe he works for the Air Force as well. So each installation does have a geospatial program. And because this is a brand new system upgrade, not all installations are part of the cloud, but eventually everyone's going to be part of the cloud enterprise system, which will allow any installations access to all of the tools that I just presented. I just created applications that pulls data from hosted features already within the enterprise or local published hosted features. So yes, in a way, you can create the same stuff that I just demonstrated. Hopefully that answered your question. And then from Daniel, Juan, thank you for your presentation. What is your next step as a result of the project? Do you present at work? So yes, the next step it is to present this capstone or this proof of concept to my leadership, because I do want to apply the same concepts to other data layers, such as utility systems, water systems, electrical systems. So the Air Force has been lacking on the data stewardship program, where a lot of the updates that occur are not validated by the subject matter experts. So we find a lot of the incorrect information when they're digging, especially during construction projects, when they're digging and making holes in the ground, they end up finding data that is technically not being tracked by any of the GIS systems. And sometimes the information is not related to the system of records. So it creates a lot of confusions, and it costs money to fix those mistakes. So the next step, it is to present it to hopefully make it a bigger solution. Thank you.
All right, well, great job, Juan. We are about out of time for this session. So I just want to say congratulations to the three of you for getting through this step of your capstone. This was all excellent. And we'll wrap it up there for today. Just a reminder that there's one last session of capstone presentations tonight starting at 7 o'clock. So be there. But aside from that, thanks everybody for joining today, and we'll talk to you later. See you, everybody.